Hello and welcome to the Graphing with Polynomial Rational Functions Part 1 video. In this video, we're going to be continuing the two problems that we worked on the features of polynomial rational functions Part 1 video, but now we'll be including a table as well as a graph. So just a reminder, problem number 5 was f of x is equal to negative 3x minus 9 over x plus 4. And the important features was that the vertical asymptote is x is equal to negative 4. The horizontal asymptote was y is equal to negative 3. The x-intercept was negative 3, 0. And the y-intercept was 0, negative 2.5. All these features, negative 2.25, excuse me. There we go. All of these features were found in the last video, so feel free to go take a look at that if you have questions about how we found those. But all we're going to do in this video is make graphs, or make tables, draw graphs. So when we're making a table, in this case, it's going to be different than our transformational rational functions, because we're not going to start with a parent function. There's not really a parent function for a polynomial rational function, because that would just be x over x, which is the value of 1. So instead, what we do is I'm going to make a really long line, and I'm going to give myself 3 spaces on either side of my vertical asymptote. So what I'm going to do is I'm just going to truly do 1, 2, 3 blank spaces, just like that, and then I'm going to write in my vertical asymptote, which in this case is negative 4. And then that's my asymptote. And then 3 more blank spaces. This is to make sure that we have 3 points on either side of our asymptote to make sure that we get a clear picture of what our graph is going to look like. Now, when I take a look at what x values should I choose, I make sure to do a 0.5 or kind of half a point around the asymptote so I can get kind of close and see what that behavior looks like, and then do 1 point or whole numbers from there. So from negative 4, if I count backwards by 1/2, that's going to be negative 4.5, and then we'll go to whole numbers. So we'll have negative 5 and negative 6. If I go forward, or a positive direction of negative 4.5, we get negative 3.5, and then to whole numbers. So we'll do then negative 3 and negative 2. My last thing I'm always going to make sure of is that all of my intercepts are listed in my table as well, so I don't forget to graph those. So I can see that my x-intercept is at negative 3, 0. I've got that right there, so I'll mark that in. Already done. Lastly, our y-intercept. We need an x value of 0 there, so I'm going to make sure to include that. And that y value was negative 2.25. So now we have only a few more points to find. If you're like, well, how do I find these? I'll use 1 point to kind of show you a quick way, or not a quick way, like kind of the longhand way to do it, and then you can just kind of use your calculator the rest of the way. So I'm going to pick negative 5. Now what I'm doing is I'm just going to take this number and plug it into my equation. So I'll do negative, that's still a highlighter, excuse me, there we go. We'll do negative 3 times a negative 5 minus 9 over negative 5 plus 4. So this is us plugging in negative 5, kind of like when you're finding your y-intercept and you plug in 0 for x. It's the same thing, except you're not plugging in 0, you're plugging in a new number. And I've actually decided I'm going to use some proper notation. So instead of setting that equal to y, I'm going to say that's f of negative 5, since that's what I'm plugging in. So from here, I would solve. Negative 3 times negative 5 is positive 15 minus 9 over negative 5 plus 4. 15 minus 9 is 6. Let's see, negative 5 plus 4 is negative 1. So negative 6 over negative 1 is negative 6, telling me that the y value for when I plug in negative 5 is negative 6. So that's how we would find our y values. So you can go through and you can solve by hand with all of these. You can also just use a calculator. You can plug this equation into your calculator and with different x values each time and solve that way. That's totally fine. I'm going to not do this for every single point because then the video is going to be forever. But I will let you know that, let's see, when x is equal to negative 6, the y value is negative 4.5. When x is equal to negative 4.5, the y value is negative 9. When x is equal to negative 3.5, the y value is 3. And when x is equal to negative 2, the y value is negative 1.5. But now that we have our table, let's graph. Oh, I need to drop in a graph. I'm going to pause this video. There we go. So I paused for a moment so we can bring in our graph. So I'm just going to graph what I know, starting with my asymptotes. Now remember, we do our asymptotes with a dashed line. So when x is equal to negative 4, it's going to be a vertical line because it's all when x is negative 4, dashed line. And then our horizontal asymptote is when y is equal to negative 3. It's a horizontal line. We have our asymptotes. You can also mark in your x-intercept and your y-intercept at this time. And now we can do the rest of our points. So let's see, we'll have negative 6, negative 4.5, we'll have negative 5, negative 6, we'll have negative 4.5, negative 9. Okay, so we have our 3 points here. Remember to connect all of your points and extend them all the way to the end of the graph so we can see the behavior. And then for my last section, negative 3.5, positive 3, so that we can see it's getting really close to that asymptote. Negative 3, 0, we've already done. Negative 2, negative 1.5, and then we've also graphed our y-intercept, which I think gives us a nice extra curve. Whoop, there we go. See what that looks like. So the graph still looks fairly similar, but we would not have been able to use our transformational table to get there. So this is making a table, drawing a graph. Let's try this as well with problem number 7. So problem number 7, let me make sure I have all the proper, there we go. So let's see, problem number 7 is f of x is equal to 2x minus 8 over x minus 2. The important features is that the vertical asymptote is x is equal to 2. The horizontal asymptote is y is equal to 2. The x-intercept is 4, 0. There we go. And the y-intercept is 0, 4. Again, all of these features were found in the last video, so feel free to go check that out if you want to see how that was found. Also, you may notice in this case, the vertical and horizontal asymptote are the same, and the x and y-intercept have the same values. That is not always the case. I just want to show you that, yeah, that happens sometimes. So let's make our table. When we make our table, remember we're going to leave 3 blank spaces, 1, 2, 3. Then we'll write our vertical asymptote since that's our x value. I think I stopped recording. I got us going again. So our vertical asymptote is x is equal to, so in this case that's 2 asymptote. And then we leave 3 more blank spaces, and this ensures that we have 3 points on either side of our asymptote to make sure we can see the full look of the graph. So when we pick our x values, we're going to go backwards, or minus 1/2, or 0.5, so that'll be 1.5. And then we'll go into whole numbers, so that'll be 1 and 0. To go forwards, we're going to add 0.5 to 2.5, and then head to whole numbers of 3 and 4. Next, I'm going to make sure that I have all of my intercepts listed. So we have an x-intercept at 4, 0. That's that last point here. We got that on there. Then our y-intercept at 0, 4. That's the very top one there. All right. So we have all of our intercepts. It's up to you whether you want to take these points and kind of work through them by hand and figure out what the y value is. You can also use your calculator, that's fully allowed. With knowledge of a teacher, I'm gonna let you know that when the x value is 1, the y value is 6. When the x value is 1.5, the y value is 10. When the x value is 2.5, the y value is negative 6. And when the x value is 3, y value is negative 2. Feel free to try that on your own to see what you get. I'm going to pause this video to bring up the graph. Now that we have a graph, we're going to graph all of our information. So first, our asymptotes. Our vertical asymptote is when x is equal to 2. And our horizontal asymptote is when y is equal to 2, so it's going to be a flat line there. And then let's see, my x-intercept is at 4, 0, and my y-intercept is at 0, 4. Those are all my important pieces. Let's move on to the table. So when we look at the table, 0, 4, we've already graphed that. We also have 1, 6, which is here, and then 1.5, 10, which is about there. So we can see how it's getting really close to the asymptote over here, and then from then on you can kind of just swoop it out and show that, yeah, it's going towards that asymptote. On my right side, we have 2.5, negative 6, 3, negative 2, and then 4, 0 we already have. So we can connect our points here, but don't just leave it here. Make sure to continue the line to show that it's going closer to the asymptote. That's what we have right now. That was graphing with polynomial rational functions part 1. In part 2, we'll look at more difficult equations, as well as we'll be talking about holes. So see if you remember what those are about. Let me know if you have any questions. I look forward to seeing you tomorrow.